Okay, I'm out of breath. I just finished walking my dog. My thing didn't, it literally died. It literally died. It's fine. I'm gonna leave the notes that I already have on, and I'm just gonna like highlight the areas that I'm gonna need so that I can explain. I'm sorry, I'm panting. Okay. Oh, one thing. You have to go back to the last time, like the notes from last time we did tutoring. Look at Jasmine, this one. This one is what we're going to talk about because last time I guess we had done 3.2, which is what I'm going to go over right now. So I don't know if you remember, we had to do with multiplicities. It had to do with the fact that it's going to look like one of these. Like your graph is always going to look like one of these. And something that you have to know is, sorry, I'm still out of breath. So your graph is always going to look like one of these, and you have to look for the leading coefficient test and behavior, all of that stuff. Just definitely look back at these before you actually get into the, before you actually start listening to this. But I'm just going to go back and I'll do like random little revamps. So basically, using the leading coefficient test to determine the end behavior of the graph, we're going to look first at this one because this is your leading coefficient, okay? I'm going to tell you straight up before we do any of the other things that we have to look at one thing in all of this, in all of 3.1, 2, 4, whatever, on and on, forever and ever. All of those, you always have to make sure that all of that, sorry, I'm still out of breath. It's funny. All of this, on and on and on. You have to make sure that they're always in standard form. What does standard form mean? Standard form means that it's from highest degree to lowest degree. So, standard form, that's funny, I think that stands for something else, but if I gave you negative x to the power of 6 plus 6x to the power of 7 plus x to the power 3 plus x to the power of 4. And it doesn't matter if there's negatives or pluses. I'm just going to put a negative in here just to make it more familiar. If I asked you to put that in order, standard form, what would you do? You would have to put from highest degree to lowest degree. So that'd be x to the power of 7 minus x to the power of 6 minus x to the power of 4 plus x to the power of 3. It doesn't matter what these are. It doesn't matter. It's about which one has the highest degree. And that's going to be your leading coefficient, okay? So this one over here is going to be your leading coefficient. If I was asking you to find the end behavior of yada, 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 and you told me that it was this one, and you didn't put it in here, your answer would be wrong. Your whole entire graph would be wrong. So you always have to make sure before you start any of this that your stuff is in the proper order, okay? Okay, let's go back over here. So first of all, is it in the proper order? Yeah, because this is greater than this. So we're going to do it in the proper order. So what are we going to look at? When we're looking for the graphs, for the end behavior, we look for two things. We look for whether it's even and odd, the degree, and we look for whether it's positive or negative with the, sorry, I'm still out of breath, with the, what did I put this as? With the leading coefficient. Leading coefficient. Okay, cool. So what's our leading coefficient? We have it right here. It's our highest degree thingy. So if your degree is even or odd, if your degree is even, then your graph is going to be even. If your degree was x to the power of negative 3, then it'd be odd. Cool? Cool. Okay, now, so for this one, in this case, is it even? Yeah, that's why I circled it from before. It's because I had to do this twice. So it's even because we have an even one. Now we're going to look for whether it's positive or negative. We look over here. Okay, in this case, it's just an x, but that means that there's a 1 in there. It could be 2x to the power of 4. It could be negative 2x to the power of 4. If it was negative 2x to the power of 4, that means it would be negative, so that'd be that one. But in this case, we have a little positive 1. That means it's this one. Okay? I literally feel like Mr. Scott. Like, he does these ed puzzles, and I think it's the same way that I'm doing this right now. And you can always hear him breathing, which is scary, but whatever. So now you hear me breathing. Okay. So this one's going to be positive because it's positive and it's even. So if you have these different, I'd written this out before. These are the different types of graphs that you're going to have. Let me move this like this because they're separate. It's either going to be down, down, up, up, down, up, down. Okay? And that means like it's falling right, falling left. I mean, falling left, falling right, rising left. I mean, rising left, rising right, falling left, rising right, rising left, falling right. Okay? It's going to be one of those things. And that's how you write out end behavior. It's by falling, rising, that fun stuff. So if you said that it was even, okay, that means it's going to be a down, down, or an up, up. If you said that it was positive, that means that it's going to be either this one or this one, or this one. But because you said it was even, that means it's going to be one of these two. And because you said it was positive, that means that it has to be this one. Right? Yeah. So your graph, I like to think of these as basically blueprints. When it asks you to find your end behavior, which I would say you need to find your end behavior when you have to do graphing. I'm almost sure you need to. I always do. You find your end behavior before you graph anything because it's your blueprint. It's going to tell you whether your arrow is going to point down or whether it's going to point up and where. And it also is kind of like a backbone so you can know if you're actually doing this wrong or right. Okay? So in this case, your thing would look like this. And how would you write that out? This would be rising left. Well, I wrote it over here. Rises left, rises right. Right here. Cool? And this next one. This one is a little bit different, okay? This one's a little bit different, and I chose it because it's different. It's not going to be for your degree, for like the degree part. Let me put degree. And, well, actually, I don't have to write anything out. For the degree part where you look to see whether it's even or odd, this part, you're not just looking at this one. Because there's parentheses. Anytime there's parentheses, you have to be aware that this is worth 1 and this is worth 1. So when there's parentheses, what you have to do is add them. So you have 3 plus 1 plus 1, which is 5, right? 3 plus 1 plus 1, I just made them 4, I don't know why. Anyways, is equal to 5. But lucky for you, 5 is still odd. So it's going to be one of which ones? It's going to be one of these two. I kind of spoiled the answer, but it's fine. It's going to be this one or this one because it's odd. Now we're going to look at the leading coefficient. When you look at the leading coefficient, this is different. So when you're looking for whether it's positive or negative, you can still look at the first one, which is that 2. And is that 2 positive or negative? Positive, right? Positive. So then you would look over here because this one is positive, this one is negative. I remember when I did the tutoring last time with you, I told you if you wanted to find out which one is negative, which one is positive, literally it doesn't matter what's going on over here. It matters, wait up, let me do it in a different color. From this point to this point, if you connect them, is this a positive or negative slope? Positive. From this point to this point, if you connect them, is it a positive or negative slope? A negative. So because this one is the one with the positive slope, that's the positive one. So that means your graph at the end of it, if we ever graphed this, which we're not in this situation, it's going to look something like this. This is always going to change. I mean, not always, but often this changes. But at the end of it all, it's going to look like one side, it's going to be odd. You know, it's not going to be 2 things facing up or 2 things facing down. And it's going to always fall left, rise right. Okay? Now we're moving on to this one. I'd written so much on this one, and I was actually like, it was good. For this one, we're going to start off with this. I'm going to just highlight as we go. So the degree even, okay, so we have to look at the degree. Let's look at the first one. That's your leading coefficient. First of all, actually, before we even start, is it in the right order? Yes. So then we're going to look over here. Okay. I'm going to get a little highlighter and I'm going to make it kind of small so that it functions properly. Okay, the degree. Oh no, it's not small enough. Okay, we have the degree. That's 4, right? Is that even or odd? Even. So that means it's going to be one of these because we cut out the odd ones that look like that. Okay, so it's going to be one of these. Now we look over here. What's the leading coefficient? 1. Is it positive or negative? Positive. So then, is it going to be the one that faces up or the faces down? The faces up. Cool. Now, we have that. So now we have That's just to give us our blueprint. So we know at the end of it all, your thing, actually I'm going to keep it highlighted. Your graph is going to look somewhat like this. At the end of everything, it's going to look somewhat like this. So now what we're going to do is we're going to actually grab the normal, because now we have to graph. So we have to grab this original function and we're going to solve for it. So we're writing it out over here. There it is. We wrote it out. And now what's the first thing we're going to do? We're going to factor. Now what are we going to factor out? What do you notice that all of them have? I'm asking these questions rhetorically, but these are the questions you should be asking yourself while you're graphing. So what can we factor out? What do all of these three terms, 1, 2, 3, what do they all have in common? They both have two x's. I mean, like an x squared. So then we have x squared here. I'm going to follow along with the thingy. X squared times x squared minus 6x plus 9. Okay? I'm going to pause for a second so that you can like really soak that in. Just look at the example. Because we took two x's out of here, two x's out of here, two x's out of here. Okay? And pretend that it's equal to 0, because in math, everything is imagination, honestly. So we just have to pretend it's equal to 0. Oh my gosh, I really pray that it's picking up my audio right now. Julie, this thing picks up your audio without you, like, right? Like, if you put, like, recording with audio, it picks it up, correct?
I think that's right.
Oh, please. I'm going to pause.
Oh,
Just.
yeah. Are you screen recording?
Yes.
Yeah.
It's picking up my audio right now?
Yeah.
Whether or not I'm recording anything? Like, I'm screen recording, but, like, whether or not I'm, like, doing a video?
Yeah.
Okay, good. Oh my gosh, praying. So it's equal to 0. Okay? So we have that little thing equal to 0 because math is imagination, and we're finding zeros. So you have to set everything equal to 0. So then what we do after that, we factored this out, but you can still factor this bottom part out more. You can still factor it out more. So what are we going to do? We're going to factor that x squared minus 6x plus 9. So we have, I like to write it out like this again. I don't know if it helps you or not. Let me know after this if it helps you or not. But AC, because this is A, this is B, this is C. I'm connecting the terms, you know? So if A times C, which is 9, is when you multiply them, it's equal to B, which is -6. What would the numbers be? Okay. It would be, always remember that it's when a negative times a negative happens, it's still a positive. So that's how it's going to work. So it's -3 times -3, and that's what equals 9, and then -3 minus 3 is equal to -6, okay? That's all over here. Now, I'm going to show you something kind of fun, kind of annoying, but it's okay. So basically, we have x minus 3 times x minus 3, because remember, you always have to open up your little parentheses, okay, when you're factoring. So we open up our little parentheses, and we have x minus 3, x minus 3. So then you have to set it equal to 0, right? So then we have x minus 3 is equal to 0, x is equal to 3. Got it? So then we have x is equal to 3. But here's where I'm going to stop you. And we're going to go on a little detour, on a little rant, because you need to understand it. X is equal to 3, but x is equal to 3 2 times. You know, if you were to write this out, it would be x minus 3 to the power of 2, right? Like if you were to conjoin these little guys, right? Or you could just think of it like there's 2 of them. There's literally 2 of them right in front of your face. There's 1 and 2. So both of them count as zeros. But here's the thing. You're going to just say that it has a multiplicity of 2, okay? And now I'm going to go on a little detour. My little detour is over here. Multiplicities are how many times a 0 shows up, okay? That's just, you just need to know that. And that you're going to need multiplicities when you're graphing, and I'm pretty sure you're going to need it in the test. So you have to understand this. Multiplicities are how many times a 0 shows up, okay? Just think multiple, okay? When there's an odd number of multiplicities, okay? What I mean by odd number is this little area. Hold up. Let me make this less ugly. Okay? This is your multiplicity. This, for example, is an even number of multiplicities. There's a multiplicity of 2, right? An even number. If there's an odd number, what did I do? Redo. Okay. If there is an odd number of multiplicities, okay? odd number. That means 1, 3, 5. That means, let's just say x is equal to 0. And 0 only shows up once. X is equal to 1. And x and 1 ended up showing up 3 times. Let's just say it was x plus, well, it'd be minus because it's backwards. X minus 1 times x minus 1 times x minus 1. That means that x, that's not a 1, that's 3. Anyways, that means that 1 showed up 3 times. So it would have a multiplicity of 3. Okay? If it was x is equal to 2 with a multiplicity of 5, all of these would be odd, okay? And when it's an odd number of multiplicities, see 1, 3, 5, anything like that, when it's an odd number of multiplicities, it's going to go through the x-axis, okay? Through the x-axis. Now, when it's an even number of multiplicities, 2, 4, 6, if it was x is equal to 0 and 0 shows up 2 times, if it was x is equal to 1 and 1 showed up 2 times, that means that it would be x minus 1 times x minus 1, okay? If it was x is equal to 3 and there's a multiplicity of 4, there just so happen to be 4 3s, then you would have your, when you're graphing, your line would touch and turn. And I'm going to explain that down here, okay? Let me just take that off, and let me take all these off so that you can see, okay? Let's say, I can delete this over here, and I can delete, actually, no, I'm probably going to need that. Okay, let's just say you had an x is equal to 0 with only 1 multiplicity, an x is equal to 3 with a multiplicity of 2, and an x is equal to 1 with a multiplicity of 1. Let's just say those were your zeros, okay? These were your zeros. So we have 0, well, over here, 0, 1, and actually this is 0, this is supposed to be 0, 3, and 1. That doesn't really look like a 3. 0, 1, and 3 is going to be over here, okay? What are we going to do? Okay, you have 0 with a multiplicity of 1. In this case, I had written out that your graph, let's just pretend we did end behavior, okay? We did the end behavior, we had a set of numbers, we had a set of numbers that looked like this, for example, and we had gone through this test, and we figured out that it was going to fall left, fall right, so it's going to look like this one, right? That's your blueprint, and we're going to need that because this is why you need your blueprint. You need to know if your line is going to go from here and go through, or if it's going to go from here and go through, whether it's going to start from the bottom or the top. So if you know that it falls left and falls right, that means we're going to have to start from the bottom. You got me? Again, you can always rewind. That's why I kind of like the idea of videos, because you can rewind me. So anyways, let's go through. I'm going a little forward ahead of myself. We have x is equal to 0 with a multiplicity of 1. How many are there? Is it an even or odd number? It's odd, right? It's odd. What happens when it's odd? It passes through the x-axis. So what does that mean? That means we're going to start down here, right? Because of this. And we're going to go through the x-axis, okay? Now we're going to 1. We're going to go to 1. I don't know why I put it in this weird order. That's not helpful. Let me just move it around. Let me just move it around so that it doesn't... Oh my goodness. Let's just move it around so that... Oh my gosh. It's more organized. There we go. So we have x is equal to 1 with a multiplicity of 1. So that's your little dot over here. That's the one over here. And since it has a multiplicity of 1, 1 is odd again. Okay? So that means it's going to go through the x-axis. So it's going to look like that. And then, also always remember that these are curved and that they're continuous, okay? So then, we have this last one over here. X is equal to 3 with a multiplicity of 2. Now, 2 is what? Is it even or odd? It's even. So because it's even, what is it going to do? It's going to touch and turn. And I'm going to explain what happens there. You're going to curve, because you have to come back for it. You always have to come back for your zeros. So you curve up, but you're not going through again. This time, you're going to curve up, and you're going to go back down. Okay? Because you touch it, you go up, and you turn. Get me? So, we're going to go up, back to it, and turn. And it goes down. And then, does this look like this? Yes, so that's how you kind of would be able to check yourself. We're going to do another example so that you can, because we're going to do this one right now, because we're actually going to graph it, and you're going to see why all of this matters, okay? Let me get all of this out. These little zeros and stuff like that. So you're going to see. Also, just to remind you, this is a polynomial function because it's constant, it's fluid, it doesn't have any stops, and because it's rounded. I have little edges. Oh my gosh, I need water. My throat hurts so bad. Okay, so now we're going to actually do one of these. We already kind of factored. We found, remember down here, that x, this is why we even went on the little tangent, I think that's what you call it. We found that x is equal to 3 with a multiplicity of 2. So what's going to happen? It's going to touch and turn. I would just always, for me, when I'm graphing, if I have to continue, touch and turn, TT, I would just like write them next to it so that you're aware and you remember, okay? Then we're going to go back to this. Now I'm going to go on another random little tangent, which is this, what I had written before, which obviously you don't know about because it deleted, but okay. This x squared still counts when you're trying to find your zeros. If you had factored this out, this original thing, and let's just say by some random thing, it was 2 times x, whatever, it's something like that. Let's just say if it was 2 on the outside. This 2 really doesn't matter. You could care less about it. It does not matter because it doesn't have an x attached to it. But because there is an x, there, that x also has to be equal to 0 because that x is a 0. So if it was x, just x, it would be x is equal to 0, and that's with a multiplicity of 1, right? But now let's go back up here. You have x squared is equal to 0. First of all, I'm going to tell you, point it out to you. This has to the power of 2. Obviously, you've seen that. Obviously, you see that. But the thing is that because it basically tells you right away that this is going to have a multiplicity of 2 because that's x times x. So you can say that x is equal to 0, and then that's going to have a multiplicity of 2. Why did I have 1 there? That's ridiculous. Multiplicity of 2, okay? I don't know if you understood that. I would give you another example. Let's just say it was 2x. Wait up, sorry. Let's just say it was 2x to the power of 2 is equal to 0, because we set it equal to 0. Then you would do the same thing. You do over 2, you do x is equal to 0, square root, x is equal to 0, but it's going to have a multiplicity of 2 because of that. It's the same way that if you get something like over here, where these two, where you combine them, it was to the power of 2. Okay, let's just say you factored something, and you got an x minus 4 times x minus 4, which is equal to saying x minus 4 to the power of 2. Because it has that little power of 2, that means that it has a multiplicity of 2, as you can see here. If this was to the power of 3, then that means that this has a multiplicity of 3. Okay? I really hope you got all of that. It's the only downside that I can't really hear your feedback. So now we're going to continue. So we know, our x's over here. Okay? Sorry. We know that these are our zeros, and we can actually start graphing, I think, because we found our end behavior, we found what our zeros are. I don't think I ever wrote down the steps for doing this. Well, first you find your end behavior. Oopsies, that's not end behavior. Then you're going to find your zeros. Then you're going to find your x. This one, I think it had to do with y-axis. Well, it depends, and this is slash weird point, and I'm going to explain that later. Don't worry about this right now. Don't worry about that right now. We're going to get to that when we get to that. Okay, so we can put in our points. I'm going to do them in blue because why not? I kind of want to. So we have x is equal to 3. Okay, and we have x is equal to 0. Cool. Now, we're not done. Let me make sure I'm doing this right. I want to check it with my old thing because girl, if I'm telling you anything wrong, and E. Nope, we're good. Okay. Oh no, why? I don't know why I left it. It's okay. It's fine. Okay, so we're going to continue. So, okay. We got that. Sorry, pause. I'm just making sure that I'm doing it right. Okay, so this one has so x is equal to 0 has a multiplicity of 2. So what is it going to do? It's going to touch and turn. Oh yeah, I never wrote that down. Let me write that down. Oh no, my pen dying. My pen dies, I swear. T. Okay, so this goes, and we know that it's going to look like this, right? This is how you're going to know, again, whether it goes from down, whether it starts from up, or whether it starts from the bottom, okay? It starts from up because we know it's going to look somewhat like this. So, we start up here. We put that little line. Oh wait, I'm going to do it in blue. Oopsies, sorry. We're going to start up, and we're going through it. And what's happening? Does it go through the line? Does it go through, or does it touch and turn? It touches and turns. So we go, this is how the touching and turn works again. Let me just do and turn. Okay, so do and turn. Okay, but now we have to come back for the next 0 because we can't just leave the 0 hanging there, so we're going to come back. Bam, we're back. And what does it do? It touches and turns too. So we touched, and then we turn. Does this look like this? Yes, right? And you're going to be like, oh, that's cool. Maybe you're not going to say that, but it touches and turns, and that's why they look the same, and they should look the same. That's how you should always check yourself. But now we're going to have to find a couple of other things, sadly. In this case, we're not going to find the y-axis because the y-intercept. Oh my gosh, why did I put axis? I meant to put intercept. In this case, we're not going to find the y-intercept, though. Why do you think we're not going to find it? Because the x literally goes through the intercept already. So if it asked you what the y-intercept was, it equals 0 because it passes through at 0. But what we might actually have to find, I don't know if right now this is going to make you find it. I think when I was taking the test, I didn't even know if I was supposed to find it, but I think I ended up doing it in the test just to be safe. You have to know you have to know how far up this goes. This little hump. Sometimes you're going to get humps that are like, I don't know, maybe you're going to get a hump like this, and you need to know how far down this little hump goes. In some of the cases. In this case, I think you do need to know how far the hump goes. Because you're not looking for a y-intercept or anything, we're going to have to find this, okay? So what did I do last time to find this? And we could just do it again. Let me look at what I did, though, because I'm going to give you what I did last time, because I want to make sure. What did I do last time? Oh, I really went off. That's ugly. That's, like, really ugly. Okay, well, we can do that, though. We can do that. Okay. What I did was I picked I picked the number right in the middle. So I picked right here, which is honestly smart. Sometimes it'll be an odd number, like it'll be like, let's just say this will be shifted over to here, so then you can just pick this one. But in this case, it isn't. So that means I ended up picking 1.5. Okay, this is 1.5, and that's going to tell us how far up this little hump is going to go, if it's going to go there, or if it's going to go here, and it's going to be like that, okay? So it's 1.5. Sorry, we're going to go look. So what we do, that's your x, right? So you're picking the x 1.5. So what we're going to do is you're going to insert it. This is what I'm talking about with the weird point, okay? This is the weird point. You're going to insert it for your x's, okay? And you can use your calculator for this. I'm going to use my calculator for this. So we have 1.5 to the power of 4 minus 6 times 1.5 to the power of 3 plus 9 times 1.5 to the power of 2. Okay, so I'm going to put it in the calculator. 1.5 to the power of 4 is equal, well, we're just going to leave it there, minus, it's equal to 5.0625. You should like follow along with me for this. And minus 6 times 1.5 to the power of 3, which is equal to negative 15 point something, something, something. We're going to add that to 9 times 1.5 to the power of 2, and it's going to equal 5.0625. Okay, so that, where are we going to go? We're going to go up to it's 5.0, so just say it's 5. I'm going up all the way until 5. And let's just erase this little hump because she has to go up a little higher. And we're going to go up, whoops, we're going to touch and turn, go up, come back down like that. And this is your finished graph. Okay? I really hope you followed along. If you didn't get something, go back and pray that I talked about it. Or look through it, see if it clicks, I don't know. We're going to do another one though. We're going to do this one. It looks a little different. Why did I choose this one? I honestly don't know why I chose this one. Oh, I chose it because it's different. Wait. I don't like that question. I wanted to choose a different question. I don't like that question. Why didn't I like that question? I think I wanted to give you like a negative one. Let's go over here. Let's look. Did I do this one? Yeah, I did do that one. That one was ugly. Oh, it's because these don't have variety. That's so sad. There is no spice in these, so I guess we're just going to do it for extra practice. That's kind of annoying because it didn't give you like a negative or like a fraction, so she better not give you a negative or a fraction in the test because I genuinely cannot come up with one of these polynomial functions. I don't know what would happen. Terrible, scary things. So let me just move this to the side a little bit because I don't want it to get in my way. Moving that down there. I'll send you this too. This whole little page. Like, I'll send you everything. I'm sorry. I think I have allergies. I'm not sure. Anyways. Okay, we're going to look at this one. This one's a little bit easier than the last, which is good. We can take a little bit of a break. It's not going to be a crazy break, but, you know. So, what do we look first for? First is end behavior. Second is, I want you to answer to yourself, see if you remember. Second is, I'm not going to lie, I forgot, but I didn't forget zeros. There we go. Zeros. And third is y-axis / funny point. Okay, so what are we going to do? We're going to start with the 4. Oh my gosh, I really pray that the recording sounds. Let me stop it here and check.